Hello and welcome. So today we're going to be continuing our discussion on parabola. Um, we're going to be adding in a couple of extra terms here um, and kind of look at some aspects of the parabola that we haven't touched on yet that will be useful for um, like basically for pre-cal going forward. So um, it's interesting for this particular class, but something that you're going to need to be familiar with like more down the road, which is why we're not going to go into super big detail about like where all this comes from and all that kind of stuff. Basically, the thing to know here, we're already familiar with the term vertex, right? So we know that when we're dealing with a parabola, the vertex is just a point that's in the middle of the parabola. So it's either the lowest point or the highest point, depending on which way my parabola is facing. A new thing that we have not seen yet is the focus. So the focus of the parabola is going to be a point that is on the inside of the parabola. The other thing that we have not discussed yet is the directrix, which is representing a line on the outside of the parabola. So with our focus and vertex and directrix label, we might get something that looks like this. So I'll go ahead and label these little points. So my vertex was that point in the middle. My focus is inside the parabola, and my directrix is on the outside. So the big important detail about all this is that the focus, the vertex, and the directrix are all equally spaced. And so when we are determining the equation of a parabola based on the vertex, the focus, and the directrix, we're going to use that fact to help fill in the equation. So let's say that I was asked to write the equation of a parabola where the focus was at -5, 3, and the directrix as y equals -3. I would need to remember that the focus is inside the parabola, the vertex is in the middle of the parabola, and the directrix is outside of the parabola. So knowing that, the first thing I'd probably want to do is sketch this information on a graph to kind of see what my picture is supposed to look like. All right, so for the sake of making my picture look nicer, I'm just going to graph everything in Desmos. We know that our focus is at -5 and 3, so I'm going to go ahead and plot that point. I'm going to label it F for focus, or if you want, you can even just type focus. They told me that my directrix is at y equals -3. So the only thing that we're missing here is our vertex. So to find our vertex, we know that it needs to line up with the focus, and it needs to be exactly in the middle of my picture. So if it lines up with the focus, it's also going to be on -5 on the x-axis. And if I look at this spacing and I'm trying to figure out what's exactly between +3 and -3, I know it's going to be 0. So go ahead and put that down, and we'll just label that as our vertex. And if we've done this correctly, the spacing from the focus to the vertex to the directrix should be the same. And so if we count it out, there's 3 spaces from focus to vertex, and then 3 more spaces from vertex to directrix. So that's just a way that you can kind of make sure that you didn't misplace any of your things. So let's keep in mind that the spacing between each object is equal to 3 spaces. So I've gone ahead and added my vertex to our list of things that we know about this parabola. I went ahead and shifted everything so that the labels are in order. And I'm going to write down that there were 3 spaces between each of these objects. And what we're going to do is call that number of spaces P. So to write the equation of this parabola, I'm basically just going to use the vertex form that we've seen in previous videos. Only instead of using A in front of the parentheses, I'm going to use 1 over 4P. And then we're going to go ahead and label the vertex coordinates as H and K, just like they normally would be when we set up our parabola. So let's use the information that we know to fill in this formula. So we said P equals 3, so I'm going to change the P to a 3 and simplify the fraction. So on the bottom I see 4 times 3, which means that's going to reduce to 12. Since my A equals 1 over 12, I'm going to replace this A with that fraction in front of the parentheses. And then I'm just going to plug in my H and K where they would normally go in the vertex form. And then I'm just going to go through and clean it up. So I see the 2 negatives, which we know combine to make a positive. And we know that a plus 0 in the end doesn't need to be there, so we can get rid of that. And so the vertex form of my equation is y equals 1/12 parentheses x plus 5 squared. All right, and so if I go over to Desmos and I graph that, I'll notice my parabola crosses through that vertex in the middle with the focus and the directrix like equally spaced from the parabola. So the last thing we need to look at is how to convert this into standard form from vertex form. And to do that, basically all we're going to do is multiply x plus 5 to x plus 5 and then distribute the 1/12. So if we multiply it out with the box, right, what we have on the inside would simplify to x squared plus 10x plus 25. And then since we have the 1 over 12 in front of the parentheses, we would then just distribute. So we would get 1 over 12 times x squared plus 10 over 12 times x plus 25 over 12. And then the last thing we'd want to do is try to reduce the fractions. So the 10 over 12 will reduce to 5 over 6. So if I was asked to give my equation in standard form instead of vertex form, that would be my answer. All right, so now let's look at an example where we are given the vertex and directrix and asked to find the equation. So the vertex is -2, 3, directrix y equals -1. So I'm going to go ahead and plot those on my graph so I can see my picture. So if I have my vertex and directrix, the only thing I'm missing is my focus. Since the vertex is always in the middle, that tells me my focus needs to be up here somewhere. So what I'm going to do is count out the number of spaces, and that will tell me how much further I need to go to find the focus. So it's important that I'm paying attention to the labels so that I don't get my points mixed up. But counting out the spacing, this one's at +3, this one's at -1. So if I count those spaces, it looks like they're separated by 4 units. So if I'm at +3 on the y-axis and I want to go up 4 more spaces, that would put me at 7. So I need my points to line up. So we'll leave the x at -2. I need my new point to be 4 spaces higher. So we'll go ahead and change the y value to 7. And then I will label that as my focus so that I can see everything spaced out correctly. So we went back, I went ahead and filled in what my focus was. We said we want to write down how many spaces apart everything is. So we said it was 4 spaces from the focus to the vertex. And then from here, we would just plug into the same formula that we did in the previous example. So I'll go ahead and write down what my equation would be in vertex form. So using the 1 over 4p as our number in front of the parentheses, we get 1 over 4 times 4. Using the vertex coordinates as our h and k, we get -2 after the x and then a +3 on the end. So once again, we're just going to go through and clean this up. So I'll multiply the 2 4s in the fraction, and then I will combine my 2 negatives into make a positive. So in vertex form, the equation of my parabola is 1/16 x plus 2 squared plus 3. To convert this into standard form, I'm going to multiply the x plus 2 out twice to get x squared plus 4x plus 4. Then I'm going to distribute the fraction 1/16. Then I'm going to go through and reduce those fractions. So the 4 over 16 will simplify to 1 over 4. And then the last thing I can do to simplify is add the 1/4 and the 3 in order to combine my like terms. So the standard form of my equation would be 1/16 x squared plus 1/4 x plus 13/4. And so for our final example, we're going to look at one where we're given the focus and the vertex and need to get the directrix. So once again, I've plotted everything that I am given. I want to point out this time that notice the focus now is below the vertex, which is flipped from what we've seen in the previous examples. So it's very important that you remember that your vertex is always in the middle, which is also why it's important to label all of your things so that you don't get the points mixed up. So again, looking at the spacing, it's 2 spaces from the focus to the vertex. So since the vertex is in the middle, the directrix is going to need to go up here. So if I go 2 spaces up from -2, that would put me at 0. So I need y equals 0 as my directrix. So I've gone ahead and written that down. Once again, we said it was 2 spaces between each object, but since everything was flipped, what I'm going to do is say that the p this time is -2 instead of +2. So from here, we'll just go ahead and plug in what we know into our vertex form. So once again, the value of p goes with the 4 on the bottom of the fraction in front of the parentheses. The 4 from the vertex goes after the x in the parentheses, and then the -2 goes on the end. So we'll go ahead and clean this up by multiplying the 4 and the -2, and then remembering that when I see a plus and minus next to each other, that just turns into a negative sign. So the vertex form of my parabola is y equals -1/8 times x minus 4 squared minus 2. So once again, to get standard form, we're going to multiply the x minus 4 twice to get x squared minus 8x plus 16. Then we'll distribute the -1/8. Then we'll notice that multiplying by a negative number does flip the signs. So the minus 8x becomes positive and the positive 16 becomes negative. Then we'll go through and reduce our fractions. So 8 over 8 becomes 1. 16 over 8 becomes 2. And then the last thing we're going to do is combine our like terms. So if I do -2 minus 2, it gives me -4. So the standard form of that equation would be y equals -1/8 x squared plus x minus 4. That's all I have for this one. I will see you guys next time.